Previously, we looked at single register transfer. Now let's look at multiple register transfer. In multiple register transfer, you want to transfer between multiple registers and memory and the processor in a single instruction. It is more efficient than having to perform several single transfers. In this kind of instruction, you will use a base address or a starting address register. And this kind of data transfer instruction is used for moving blocks of data instead of data from one memory location. It is also used for saving context and in stacks, which we will see later. So the way it works is that it will use this instruction LDM for load and STM, which stands for load or store multiple. When you use this instruction, the whole register bank or a subset is copied to memory or restored within a single instruction. So this figure here shows what happens when you perform LDM. When you perform LDM, it loads a bunch of data from many memory locations into your register. When you perform a store multiple, then it takes the contents from your register and loads it into or stores it into multiple memory locations. In general, the syntax for load multiple and store multiple is like this. The instruction is either LDM for load multiple and STM for store multiple. It has optional addressing mode and condition code. And then RN stands for the register which contains the base address. And then you will also have the registers where you want to, with the address for the memory locations. Okay. There are different modes that you can use, which you will use here in the addressing mode. You have IA, which stands for increment after, IB, which stands for increment before, DA, which stands for decrement after, and DB, which stands for decrement before. Now, if you just leave it as LDM without any mode, then by default, it will take increment after as the addressing mode. When you use the increment after or increment before addressing modes, you will perform increment of the address of the memory for each data that you want to load from or store into. For decrement after and decrement before, the base register address will be decremented after or before you perform the instruction. So let's look at some examples to get a better understanding. Let's look at an example of using the LDM and STM operation. So as a recap, the syntax is as follows. You have the LDM or STM, the optional addressing mode, the optional condition code, the base register, where it stores the starting address of the memory location. This is the optional write back if you want to change the contents of the base register after you perform the instruction, and then your list of registers. So here are the different addressing modes. Now let's look at what happens if you use the load multiple. And remember, this is your base register RB, and it contains the address of the memory location where you want to start from. So R10 contains the address, and let's say it is pointing to this particular memory location. Now, if you are using the addressing mode increment after, then you are loading, so meaning that you are loading from the memory into the register. So the contents from the base register address is going to be loaded into register 0. And then 4 addresses after that is going to be added, transferred into R1, and 4 addresses after R1 is going to be transferred into R4. So we are talking about increasing address here. So the address increases from bottom to top. So why is it that you are taking memory from memory locations four addresses away from each other? The reason being that each register can take 32 bits, whereas each memory only contains 8 bits. So it will take 4 blocks from the memory and put it as a 32-bit. So that's why you jump 4 addresses on top of that to get the next value and store it into R1 and so on and so forth. Now for STM, it works the other way around. Instead of storing the data from memory into register, you are storing from register back into memory. And it first looks at the base register where it needs to start storing, and then it stores R0 into the base register, R1 into the address four addresses up, and then R4 4 addresses after this address. Now in the case of increment before, you increment the base address before performing the transfer. That's why you don't transfer it in the base address. You actually transfer it 4 addresses up and so on. In the case of decrement after, you start from the base address, but instead of storing or loading from the beginning here, you start from R4. So R4, it will be the last register will correspond to the base address. And the one before it, which is R1, is 4 addresses below, and R0 is 4 addresses below this R1. When it's decrement before, then the base address is decremented beforehand. That's why you don't use this base address to store or to load. You actually use the 4 addresses below it, and the 4 below it, and the 4 below it. Another thing to note is that the register list is enclosed within curly brackets and not square brackets, which we have seen before with LDR. So curly brackets and not square brackets. Let's look at some examples where you have the write back option included. So here are some examples using the store multiple, and we have increment after, increment before, decrement after, and decrement before. Now if you have the exclamation mark here included, it means that you want to write back. Now write back means that you want to update the base register address. So this stands for the base address in the register. Okay. So what happens when you have this kind of instruction? What will happen is, looking at the base address located in R9, it knows that the memory location is 100C. So it increments after, meaning it stores first the values in R0 into 100C, and then the next memory location will get the value at register 1, and R5 will get the next value from the next memory location will get the value from R5. And then increment after means that the base address will be incremented after that, so it will have a new base address, and that will be updated. Similarly with store multiple but increment before, the only difference is you increment first. Therefore, instead of storing the contents of R0 in 100C, you are storing it 4 bits after, which is C, D, E, F, and 0. So it's 1010. This stands for 1014. So you store it at 1010, and then the next one, the contents of R1 is at 1014, and finally the contents of R5 is at 1018. But the base address at R9 will also be updated because you have the write back. It will be updated to the new address, which is 1018. For the decrement option, the only difference between these two is your starting address. So instead of starting at the base address, when you store the values, it will end at the base address. So in this case, the base address is 100C. So the final value, which is from R5, should go there. So these two will go to the memory locations before it. So in this case, it will be 1008 and 1004. And with write back, you will also update your base address register. Okay, if the address in your list of registers are consecutive numbers, for example, R1, R2, R3, instead of writing it as load multiple increment after R0 with the exclamation mark, R1, R2, R3, you can also write it in short form like this, provided that they are in consecutive order. All right. If you had something which we had previously like R0, R4, R5, they are all of different, they are not consecutive, you can't use this short form. All right. So if you have something like this, you can also use this short form and it will perform the same thing. In this case, you are loading, the base register is given here. It's 000800010. So looking at the memory, this is the memory. Finding the address at 80010, that's your base address. The contents, because you are now incrementing after, meaning you take the value in first. So you take the value in first, the first value needs to go into R1. So that's why you see that it's being loaded to R1. And then the next memory location after that is going to be loaded into R2. So that's where you find R2. And this one will be loaded into R3. In this case, because you have write back, therefore you are also updating your address in the base register, and that will be this new address here, which is incremented after you perform the loading. This is the same thing except that instead of incrementing after, you are incrementing before. So the only difference is instead of taking the value from 80010, you increment first, meaning you have to go by 4 addresses to the next memory location. So that's why the first value that is put into register 1 is 0002. And then we have 3 and then 4. But the updated base address register is going to be 8001C, which is going to be updated here.